Okay, we should be live. All right, looks like we're live. Hello. We'll just test the sound. 1, 2, 3. Testing sound. Gonna need you guys to tell me whether the audio is good. I haven't really done any. Well, I haven't done streaming in a while, and the OBS settings might have changed between then and now. The YouTube interface definitely changed, so I had some problems figuring that out. So let me know if you can hear me, and I'll just hang out here, get set up. All right, cool, perfect. Looks like you guys can hear me. So let's see. Go back into OBS. All right, so basically, I want to stream today to take the next step in the Kube V2 design. So over the past few weeks, we've been chatting on the Discord server. By the way, if you haven't joined the Discord server yet, we have a pretty great community out there, and lots of different discussions about the hobbies like 3D printing and electronics, home automation, OpenHab. Pretty much everything's every nerd hobby you could think of is covered. Drones too, amateur radio and stuff like that. So if you haven't joined the Discord server yet, we'll post the link up here. Hoping one of these guys that are here will do so. So the reason I'm streaming today, though, is basically, a couple months ago, I showed you this design, which is the Kube V2, where basically I took my first Kube design, first Kube multi-sensor design, and tried to make it a little more modular and easier to make. So this is the first design. I have these pretty much all over the house, reporting temperature and humidity from the DHT22, and also in several cases motion. Other cases I have, well, I wanted to expand that to pressure sensors and stuff like that, but I realized that making these was not as easy as I hoped it would be. So we have the 3D printed enclosure with tabs for the OLED screen, and then wiring goes between the OLED screen and the PCB board that holds the Node MCU. I didn't think that was well, I didn't think that was too hard, but it is kind of a pain to make these. You have to depin the OLED, make the wires just long enough, and then and put melt the OLED screen in place, so you really can't remove it if it fails. You pretty much have to print another enclosure, and it's not as modular as I liked it to be. So it's not too hard, it's not too bad. I still use these and I still make these. I actually have these on my Tindy store if you guys are interested, but the designs are on Thingiverse too, so you can still make these, and I think a few people have, and they seem to like them. So I'm not going away from this design. I just think that over time I realized that I wanted to make it a little more modular and easier to make for myself and for others. So that's basically where Kube V2 came in. I wanted to have well, I wanted to get away from the OLED screen being so such a pain to install. So now basically there's a PCB. I created a PCB for the OLED, and while I was at it, I already had the space here, and one of the guys on the Discord server, CyberISSO, created or found a TE M8 sensor. These MS4 sensors right here, they have 8 different inputs like motion, light, sound, CO2, VOCs, temperature, humidity. I think I'm not sure if I mentioned that already. So there's like 8 different sensors on here that all communicate over the I2C channel. So I really like the idea of this sensor, and I had the space on the OLED screen, so I decided to put that on a single board. And then for the baseboard itself, I'll show you the original if I can find it somewhere here. I thought I had one handy. I do. 1 second. So this is the original board. Has the Node MCU pins. I had a level shifter here for the LED lights, so I use these for LED strip controllers. The level shifter I used was one of these simple I2C ones. Too slow for the LEDs, so I ended up not really ever using these. There's a couple other things that I found over time were not too great about it. So yeah, so basically I wanted to make some improvements to that board. So here's the board. Here's the new board. Zambu's hurrying me up. So all right, Sensor Spencer. Okay, I'll assemble the new board. But basically, this is the base board. There's the new level shifter that we found was a lot better. This is a 74HCT 125. Things like power selection, external connections, and the thing that I like the best pretty much about this is the I2C interface. So I broke out the I2C pins so I could make all these submodule boards. So this is the OLED board. Snaps right onto the base board, and it basically is a module. So going from that, in this live stream, we will look at these 2 new submodule boards that I created for the Kube sensor. So the first is a power supply module. So yes, you can power the Kube through the USB interface on the Node MCU. You could potentially power it from these external connections here as well, and I've done that for my LED strip controller. But we wanted to have a little more versatility in getting power for these sensors. So I've created this submodule board that will sit between, or well, it could sit anywhere in the stack basically, because it just provides power to the I2C bus pins, the 5-volt pin and the ground pin. But I think my idea is that it will go in between the OLED sensor and the baseboard sensor, and there's 3 different options. Now, as of the latest design, there's 3 different options. So this actually, I took an idea from the HASP board. So if you haven't seen the HASP yet, actually I have one here. I'll show you real quick. The HASP is this device that Luma made basically, and this is it's a home automation switch plate. The original design was to put these in the wall, in a single gang wall plate, and use the touchscreen display here to control your home automation system. And I have 2 of these around my house, and I have this desktop unit, which is pretty awesome too. So in his design, Luma came up with this idea of using AC to DC power converters. These MRCs, not MRC, IRM035. It's the Meanwell power supplies. And then in this latest design, and I had that here too, and I lost it. He found a DC to DC converter that also can be used. It takes DC input and converts it to 5 volts. So there's 2 options right there. You can use the Meanwell power supply, you can use the SLC035, or there's a different type of series in these power supplies. So the bottom line is you can use just regular 120 volt AC or DC to DC, and these can handle power over Ethernet. So we're you could pretty much hook this up to a PoE switch and run these sensors off of that. But very very kind of late breaking change was I gotta bring this whole stack of stuff here. So not too long ago, Zambu actually on the chat server came up with the idea of using here's the Meanwell power, not the Meanwell, it is a Meanwell too, SLC03C TAC 05, and this converts I want to say 24 volts down to 5 volts. So I'm not going to be using that one today, but I just wanted to show it to you. I think that's an empty box. By the way, these boards came from PCBWay, and I've been using them for a long time for making PCB designs, and they were kind enough to sponsor these boards. So thanks PCBWay, and they also made me sent me a nice little PCB roller too. So Zambu came up with the idea of using these, well, basically a rectifier and these buck converters. So these DC to DC little cheapo buck converters with these cheap rectifiers is probably the cheapest way to power this device. So I definitely like that option, so I decided to add that to the PSU board design. So that's a power supply board. We'll make this board today and make sure that it works. I haven't tested it yet, so it is July 4th, and there could be fireworks, so we'll see. The other design that I want to show you today is this digital IO board, digital and analog IO board. It's basically an IO board, IO expander board for the Cube. So obviously the Node MCUs have a set number of pins you can use. Some of them are used for I2C, some of them are used for the memory, and you really only have, like, I think 6 or 7 IO pins. Maybe not even. I think with the I2C chips or I2C pins, you only have really 4 or 5 IO pins left over. So what people have been doing, and what I've seen people do, is use these MCP 23017s. There it is, MCP 23017 IO expander ICs, and that expands it to 16 channels of digital IO. But since I had all this space on board besides that 16-port MCP expander, I decided to also put the analog ADS1115 chip on the other side. So all of these are I2C. So the MCP 23017 talks over I2C, and the ADS1115 talks over I2C. So now you have, on this one board, which connects via the I2C bus to the Node MCU baseboard, you have 16 pins of digital IO and 4 pins of analog IO. On top of that, I decided to break out the address pins for the MCP 23017 module, and they give you 3 address bits for a total of 8 possible addresses on the MCP. So you could literally have up to 8 of these boards stacked up high within the Cube stack. And just to show you, some of you might have seen this before, but I've designed these breakaway 3D printed enclosures for the Cube stack. So this one would contain the OLED and the sensor board. This one would contain the baseboard, and then you have the enclosure on the back. So once you have everything soldered together and you know all the modules ready to go, you just snap them. You know, you slide that I2C header into here and snap the enclosure on. So hopefully that makes it more modular and easier to use. I haven't made the 3D printed models for these enclosures yet, but everything is going to be pretty low profile, so the stack won't be too much bigger than what it is right now, depending on how many modules you use. All right, so I think that's enough talking. So let's do this. Let's start our soldering. So and plus and minus. Okay, so cool. All right, and unfortunately, I can already see a problem. So the model I used, the library I used for the buck converter was probably for a smaller pin pitch than these modules are. So I'm not going to be able to use that here. Ugh. At least not directly. I think what we'll do is just for testing, we'll actually wait. I mean, it's just one pin, right? So if we're lucky, I think it might fit. Okay, never mind. Maybe it will fit. It'll just fit on these external ones. I didn't see. I see there's 2 pin headers on each side, but really it's just the external pin that matters. Okay, so maybe we can do this. Let's give that a shot. And then we have our rectifier chips here. Yep. I don't think we have to rig it, Zambu. I think we can actually make it work. I think for some reason I get confused when these were, I don't know if you guys can see that, the pin pitch on these 2 pins on the side is very, very tiny compared to the actual buck converter. And I know when I was looking at the libraries for this in Eagle, there was 2 different types. There was a fine pitch and a small pitch. Before you hook up to the Node MCU, power the back. Yeah, definitely, you're right. Good point and good thought. We'll definitely do that. So these buck converters out of the box, they provide power from anywhere from 5 to 12 volts, I think. So, or probably even higher than that. So they're going to be set to some voltage we might not want. So we want to provide 5 volts to this bus. So we'll definitely have to adjust it with a voltmeter, and we'll see. I think I have one here. I do. Okay. All right. So let's see. These are the rectifier chips. So we have AC on the side, plus and minus on the top and bottom. So these go in like this. Okay, so let me turn the soldering iron on, and we can start bringing in our small equipment here. Could you get the smoke back in? Yeah, Zambu's definitely played with these before. So yeah, we'll definitely try to avoid smoke and fireworks today, even though it is Independence Day in the US here. So alright. Make some pin headers for the buck converter. And I started making the address pins for the IO board. So I'll just cut one off here. All right, so what's going to be the easiest way to do this? I think we'll solder these in place and then solder the buck converter on top of it. Oh, I see what you mean. Okay, so Jim has a nice idea, but you know what? I think the pitch of the pins is tight, but the pins themselves are regular diameter. So I don't think we're gonna have a problem with using smaller what's it called? The electrodes from the rectifier. I don't think I have to do that. I just think I'll solder these in place first, and then I'll put the buck converter on top of it. Hopefully I get my spacing right here. Looks like it's okay. Just making sure that my pins match up. Out minus, out minus, out plus, plus. Alright, so polarity is good. I just gotta get the buck converter on top of it here. Oh, close. Do need to adjust a little bit. Need to convince it to get on top of these pins here. Probably should have put the pins on the buck converter first. So that's a lesson learned. Make sure in and out is correct yet. I know. Trying to. Ah, come on. You jinxed me, Zombu. I got the pins in right, but now I'm having problems with getting these headers in. So yeah, and I think the pitch might be just a little bit off. So let's see how far I get with this. I might have to redo one with putting the pins in the buck converter first, and then basically the other way around. Convince it, maybe. Yeah, looks like we got it. Alright, cool. Let me do that while it's in there. just to make sure I know I had. I think I had it all the way in. Yeah, this one's definitely bad. I might have pulled the pad on one of these, so hopefully it works the way it is. Okay. So, I don't need a 24 volt AC PSU to test it, do I? I thought these rectifiers can do higher voltage than that. I was just gonna put AC. Ken Iverson, hi, how are you? Zombo, let's double check this, because yeah, I definitely don't want to put smoke on these things. But I thought these rectifiers can do AC 110 AC, because I do not have a dual volt transformer or any other 24 volt AC power source handy. So 2W10s. Let's look that up real quick. I see what you mean. Oh, okay. Yeah, that's gonna be a problem. So I don't think we're gonna be able to test this right now, Zombo. Not the buck converter at least. Yeah, the rectifiers can handle it, but the buck converter definitely can't handle DC 120. All right, so that was an oversight on my part. I'll need to. I do have a DC power supply. I guess we could rig it. Actually, let's see. DC plus, DC minus. Yeah, I can do 60 volts. Yeah, I have a 60 volt DC power supply, but not an AC one. All right, well, good. I'm glad we have Zombo on the chat, because he's keeping us safe here. I definitely would have put 120 volts into this buck converter. So we'll bypass the buck. Bypass the rectifier until I can get an AC power supply to test that. But what we can do, and I'm gonna leave this one here. I'm gonna use the Meanwell power supply, just the AC DC one, just so we can get this board up and running real quick. So this is the original HASP power supply. 36 volts max on the buck. All right, cool. Thanks for that. Bam. DC and L. Okay, so we can do this right now. We still can't see if we can get over 88 miles per hour. I don't think my wife would be too happy about that if we set things on fire here. So let's keep the fireworks off for today. Fireworks are canceled. In that case, before I put the power supply in, I'm gonna put the fuse in. Actually, the fuse probably would have helped, right? So where did I put the fuses? had a whole bag of them here. Just not a minute ago. Oh, there they are. Okay, here we go. So one other thing that we've recently changed on this board is instead of using these regular 5x20 millimeter fuse holders and fuses on this board, which would have been way too big and taking up too much space, we've switched to these glass fuses. So they're cheap and easy to replace. So that's why we're going to be using those. Alright, so that's the fuse. Solder that in place. And then I want to put in this terminal block to connect the AC wiring in, or DC wiring if you're going to use a DC power supply. But the way I'm thinking of doing this is, I guess I need to test the fit. This is a pretty beefy power supply, but I wanted to use these holes as a strain relief. So basically have the wires go in through the top and then use these holes to strain relief them in place. So I already have the cable I'm going to use for AC wiring here, so let's see how that will fit together. Just do a dry fit right here, and it's pretty tight actually with the ferrules. If I wasn't even using ferrules, it probably would fit. So for now, I'm going to basically connect it this way. So alright, so we'll solder that in place, and then we'll still use the holes as strain relief. Just won't be able to come around the back of the terminal block. Alright, and then the meanwhile power supply, still think I want to use let's see, I want a 5-pin, no, 6-pin. So I have these headers with long legs because they're going to be going into the baseboard below them. So let's see if we can get this and then just fit to see how long, how high I need to leave them up. This meanwhile power supply is pretty high. That's without the node MCU. So let's put the node MCU in here. Yeah, with the node MCU, they need to go a little higher. So I really want to have the longest set of headers, or headers that have the longest legs I can find. And I know I bought just a set like that. Yep. Yeah, okay, here we go. The idea is to have the top of the female header flush with the highest point on the, well, flush a little bit higher than the highest point on the board itself, because you want the header to stick out of the enclosure so the top board can go into it. But you still want to have enough of a pin here to be able to reach the header below it. So again, I want to get the longest possible ones here. And even then, it's pretty good, but definitely will fit. But then the board on top of it is gonna have to use these long ones too. So that's kind of the reason why I wanted to have, you know, as low of a profile as I could with these, with the devices I'm putting on here. This mean-well power supply doesn't really have that. So using the buck converter and the rectifier would be the best thing to do. We just need to figure out a way to use it with 120 volts DC. But okay, all right, let's get the power supply in here and then we'll test for power. All right. Now, okay, actually with this one I did it the right way. So I have the female end pretty much flush with the top. So that's fine. That will work. Okay. So we'll leave it pretty flush with the top of the mean-well power supply and get it soldered in place. And now the only thing I'm going to do before we power this on, because I'm going to be putting this on AC voltage, and we're dealing with bare PCBs here, I'm going to protect this side of the board, which is the AC side, with electrical tape. So definitely recommend doing this if you're dealing with the AC voltage. which means that if we did the DC to DC converter or power over Ethernet, might be the best idea to go with powering these. So, all right, that's good. So we'll get the AC voltage, AC wires hooked up here. I'm using ferrules. And there we go. Need a zip tie to use as strain relief here. Cap and tape. Yeah, that's a good idea too. Definitely. Plasti dip, or I think, or anything that would you know, serve as insulation would be good to have on these boards on the AC side. Okay, so I think we're ready to fire this thing up. And hopefully I did everything correctly, and hopefully the fuse works if I did not. So here we go. Alright, no smoke. Need a way to get this cable secured so I don't have this thing falling off the desk every time. Let me get a meter. And again, AC voltage on. Okay. Nice. This thing's sliding off. Just secure it a little bit better. There we go. Okay, so now I need to test the DC voltage, and that's on here, on these two pins right here, which I'm not going to be able to easily get to. Let's see. It's going to be the top, or furthest right and second pin. Wait for it. Yep, it's 5 volts. All right, so let's do this. Let's power it down for a second, and then we'll throw it into the stack here, into the Node MCU stack. So I'm going to put the OLED module on top of it now. And disconnect the USB connection. And then we'll hook up the power supply module stack onto the baseboard. So this is our Cube stack right now with the baseboard, the power supply module, and the OLED module on top of that. And ideally, all of this would be in a 3D printer enclosure like this. But actually, there is a user on Discord, Pepe, who has done a lot of cool things with this so far. He actually took my old code and rewrote it to support all 8 sensors from this TE sensor, and he uses these in kind of like a bare configuration. So he uses standoffs on this side to keep the stack even. So let's see. So now, hopefully, if I power this up, nice, came right up. So now we're powering the Cube module through the PSU module, the power supply module. As I'm saying, with the PSU module in the middle is probably a bad idea. Maybe, but I think these meanwhile power supplies aren't that they don't generate too much heat, and I mean the hasp uses it in a pretty tight enclosure too. So I don't think I don't think we're gonna have a problem with that. With I don't know how it will be with the buck converter and the rectifier. So we'll have to think about that. We'll have to take a look at that long term. But yeah, that's cool. That's power supply module works pretty much as intended. But I do know, so now I know I have a couple things to take care of with this. Definitely the spacing for the pins on the buck converter. I need better silk screens. Well, yeah, I need a better silk screen here to determine AC1 and AC2 and positive negative voltage for the terminal block. And I need to, actually one of Jared's suggestion was to add a RJ45 connector onto this board so we can plug in the power over Ethernet feed. So for the DC to DC converter, that could be we could pick it up right off the RJ45. So I'm gonna make those changes to this board and then publish it on PCBWay. If you haven't seen that yet, let me show you where that is. So on PCBWay.com, I'll link to this. I shared the designs for, I shared the Gerbers for the original Cube board, including the BOM for the parts you need. And then I also shared the new board, the new baseboard with the BOM, and then the OLED and MS4 sensor board is up there as well. So once I finalize the design of the power supply module, I will share that to the PCBWay site as well, and then you guys can order it from there. So yeah, that's PCBWay definitely has the best prices and shipping as far as I can tell. Like with these boards, I ordered them last week on Monday, I think, for this one, and Tuesday for the IO board, and I had them both here, like Monday and Tuesday of this week. So 6 or 7 days shipping from order. Cool. Not concerned about heat, concerned about mains touching the MCU. So yeah, so I think the point is, if you're using this Zombo, if you're using this with the 3D printed enclosures, this would be on top of the baseboard. So the power supply module will not touch anything. The power supply module pins will touch plastic at worst. Bare like this, then yeah, you definitely have problems. But honestly, I wouldn't recommend using this bare with AC voltage powering it. So that's the first consideration. Yeah, and you could you're right. You could also put the PSU module on the bottom. But again, if we're using these, then every module is kind of sitting in its own enclosure, so it's isolated from the other modules, except for the I2C header here. All right, cool. So that was the power supply module. Kind of want to see what happens. I know we have changes to make with the module itself, but I really want to try this digital I/O module now, because this was definitely more of a thing for me, because I needed to use these analog pressure sensors. I want to use these and for monitoring my HVAC system, and obviously the analog input pin on the Node MCU is worthless. So I wanted to use the ADS 1115 to get the much finer resolution and 0 to 5 volts DC range instead of 0 to 1 volt like the Node MCU has. So Zombo's asking, well, Node MCU and PSU are in one spot? No, they're not going to be in one spot. So each board, each module is going to get its own case. Yeah, each module gets its own case. So baseboard, power supply will have a case probably just like this. Thinking about it right now. Let's try that. Let's see if it fits, because if it fits, we might be able to reuse the baseboard case. No, I'm thinking that's not going to work with the AC voltage wiring going in. Yep. So I need to figure out. So I need to just probably use the same case, but cut the opening for the wires going in and cut openings here for the terminal screws. I failed to mention the Uber thermostat. You're right. That's right. The whole reason I kind of refocused myself on this project, and I definitely kind of lost track of it with everything else that was going on with fixing my 3D printers, building an MPCNC, and a couple other hobbies that I got into over time. I kind of lost track of this project, so Zambu helped me refocus on that, because he wants to use these boards in a thermostat that he's building. So I'll let you talk about that in chat, Zambu. But I think the gist of it is he wants to have pressure monitoring and temperature monitoring of the coils in the cooling system, so you could definitely get the better monitoring on that system, and can shut it down in case something's going on. All right, so I'm gonna put this to the side here, and we're gonna try working with the I/O module now next. So let me put the modules together. So I have the ADS1115 in this version, which is the original version, kind of wider board, wider PCB. But I also ordered, just to try it out, I ordered this smaller version of it. With the same pin out, so that makes it easy. But it's about half the size of the original board. So side by side, this is what they look like. Okay. So both will fit here into this location on the PCB. But for now, well, so that's the ADS1115, and I also want to show you the MCP. All right. So the MCP chip is here, and normally you'd want to put it straight into the board, but because I'm testing and I already know there's some changes I want to make to this PCB layout, I'm going to use these socket headers to, or IC sockets, I mean, to be able to take the chip out and use it in a different board. So I don't have a full 14. It's a 28-pin IC, so I didn't have a full full-length header or socket for it, so I ended up using two together. Okay. So, let's try, let's get this header on here. Yeah, Zambu's definitely got great ideas with this stuff, so we're excited to work on this project. And the idea is it's all open source, right? I mean, everything you see here, every board I designed here is shared, Gerber files, but then even the Eagle projects. So the board and schematic that I have for all these boards, the original ones are on GitHub already. These I haven't had the time to put together a GitHub repo yet, so once I find some time, hopefully this weekend, and hopefully I'll make, I have some time to make some of the changes that I want to make here. And once I do, I'll definitely publish the project to GitHub so you guys can try it out on your own. Alright, so that's the socket header, and then for the ADS1115, again, you know, to keep it low profile, you want to solder it directly to the PCB, but because we're just testing here, I'm going to use a female header. So that we can take the ADS1115 module out after we're done testing this board. I might be making a mistake putting the tall female header on first, but oh well, too late now. So next we want to get the address jumpers in, so we can address the MCP. Well, using the soldering iron to hold it in place. Oh wait, that's way off. Good. Cool. And just while I'm doing this, I want to keep talking about the project, but the idea is to again publish this, make it available on GitHub, and then let people run with it. Like, so the baseline is really this, this, I guess I'll show it here, the baseboard without anything, but the I2C header. So whatever else we want to put on this board should be I2C capable. I do have one IO pin D4 that I brought out to the header here, and that's mainly because every LED strip controller that I've ever used or looked at uses D4 as the LED pin, the addressable RGB LED pins like ESP Pixel Stick, my code, and most examples like Broad Automation's code, Dr. Z's code. All of them use the D4 pin to talk to the LED strip. So I brought that out to the header, but the idea is, once I share these projects, I'd like to see what other people can think of with, how to use the board, what else we can use it for. So I'm kind of excited to see what happens when I share the project on GitHub. See if there's any other ideas, and if you do have them, if you have ideas here, share them, and we can hash them out. Share them on GitHub. Share them on Discord, the Discord chat. Oh wow, Dr. Z's is here in chat. Awesome. Thanks for joining the live stream. It's nice. We are working on a Kube multi-sensor board here. Let's see. Need some switches. So for the MCP 23017, the way you address it is you have the 80, 81, and the 82 pin. And I gotta remember the way I laid these out. I think left is, yep, left is 1, right is 0. So the first board will just label, or we'll just address it as 000. So it's the lowest addressed MCP module. All right, and then for these, this is another change I want to make, and I haven't really had time to do that yet, but I originally wanted to use these tiny 2-pin screw headers, right? And they're cheap. They're they're easy to get from Prime. But the problem is I didn't realize it. I haven't really used these before. When you try to stack them side by side to like this is a 4-pin header, you can squeeze them in, but they're not really meant to be that way. So actually these were 2 and 2, but for 4-pin the pitch is just slightly off. This thing's gonna make a liar out of me. No, it fits. Huh, okay. Maybe we don't have a problem. Maybe I just had a bad unit the other day when I was kind of like dry fitting them. Alright, so for the purposes of this evening, and not to keep you guys around while I just endlessly solder things to the PCB, I'm just going to populate the bare minimum of these here. So I'm going to need okay, so I'll do 2 channels on the MCP, and the way these are laid out, D0 to D16 on the MCP, and then we'll do 2 channels for the analog, 5 volt, I'm sorry, ground, and 5 volt connection. So again, the idea is that we're basically breaking out the external connections from here to other sensors and expanding the number of pins that we have available from the node MCU. Okay. Oh, you wanted it faster, Jared? I'm doing this kind of first time I'm actually working with these boards, so I don't even know if this is gonna work. But hey, you guys won't make fun of me if it doesn't, right? All right, so ideally you want to have all these populated. So the way I'm gonna make the change, I'm gonna change this layout a little bit. 4 4 4 and then 4 4 and 4 sets of 4 terminal pins for these. So you can get these in different widths. So I got the 2-pin connectors here, but I saw a pretty cheap set on Amazon of the 4-pin ones, and it should be faster to put this together if we use the 4-pin headers, and it's only a single item on the bottom too. So other than that, the only thing I need is the long set of headers here, and this time I'm gonna, well, again, ideally I don't think I need that long of a connector. Yeah, I don't think I do. So I'm gonna use the shorter ones that I was using earlier. These pins are slightly off. Okay, here we go. Cool. Again, I'll just get that in there with one pin. All right, good. Cool. So that's a finished, well, half finished, but you get the idea. Digital I/O board. All right. So we can populate the. Actually, I should do that first. We'll pop in the MCP23017 chip. Need to change the angle of the pins. Cool. All right, and then the ADS 1115. So let's see if all of this works together for now. And with the profile not being as low, it's a little tight there, but that's fine. And you know what? I'll use E-tape between these just so I don't short them out. Oopsie. You guys are having a pretty funny conversation in chat, and I'm trying to keep track of it while doing this. Cool. So OLED on top of that, or should we use the power supply? Let's see how well this whole thing stacks. All right, so that's a pretty big stack, and I don't know if I mean, this wouldn't necessarily be something you put on the wall, but still. I did not measure header length. You're right. I did not follow my own advice. So yeah, so the header height could be better. And because I use the offsets and this IC socket headers and female headers for the ADS 1115 on the DIO board, that definitely is going to throw off the height here a little bit. But the bottom line is we have a working Kube V2 stack with the power supply and, well, hopefully the IO module as well. So let's see what happens when we go into ESP Easy. And So right now, I'm going to go into the I2C scan and see what's on the bus. Oh man, look at this. PCF 8574 and MCP 23017 use the same address. Do they? No, wait. That's the OLED. 0x3C. 0x2A is our ADS1115, I think. And 0x20 is the MCP 23017. Okay. So I think we're fine. I think we're yeah, alright. Let's see see if we can pick up the device. So let me add ADS 1115. Nope. Okay, so it did not pick up the it didn't pick up the ADS 1115. Wonder why. But it did pick up the MCP 23017. So let's try that one instead. Switch input MCP 23017. Okay, port 0. So this is how you address the different pins. So D0 through D16 is port 0 through 16, or D0 through D15 is the first 15 channels, first 16 channels on the lowest addressed MCP board. So cool. Port 0 should be our channel 0. Let's just call it MCP 23017. Hit submit. And now its state is 0, right? So what's an easy way to test this with what I have here? Let me use the push button. Or actually, well, it's probably simpler to just connect wire, jumper wires here. So let's do that. Still want to know why our ADS1115 didn't come up. That's weird. Definitely double check the wiring and didn't see any problems with that. But oh well, we'll have to maybe try a different one for now. But let's try to figure out if we can get the MCP 23017 to work at least. And okay, we'll get two. I know what I'll do. I'll use the motion sensor. I was going to use that just to show you guys that sensor input. So red is 5 volts and white is ground. Oh, I'm using the wrong pen here. And the signal is brown. Okay, so we'll try using a motion sensor on the first channel here. I like your thinking, Zombo. Definitely would be nice to have a 4K camera. Alright, so we green for signal. And wow, these things are tiny. I don't even know if I have a... I don't know if I have a bit that tiny. Oh, maybe I do. Okay. And I'm going to need ground and 5 volts. So ground is here. One of the things I need to change is I put the silk screen labels for these terminal blocks on the solder mask layer by mistake. So I'll fix that. Ground. And 5 volts. Alright, and then connect it all to the motion sensor. And hopefully after we connect it to the module, get the power supply in. Alright, and power it up. That did not like it. What did I do? Oh. Maybe. Yep, that was it. I didn't have the boards together. Right, so now yeah, okay. So port 0, 0x0. Hopefully that changes if I move my hand from the screen. Unfortunately, it's pretty hard to tell if this is changing without. Yeah, it's not changing though. I wonder if I have a bad sensor here. Let's cheat and hard code it. So I'm going to put 5 volts into here. Okay, so I'll just hardwire the connection for now. soon as I find it right. Need something to be able to do that first. I have a breadboard here somewhere. I'm getting to that point where I'm losing stuff now. That's should be sitting in front of me. All right, well, we'll just use a wire. All right, so I need to connect this to 5 volts. And now, if I pick the right pin, which looks like I didn't. Let's go back into the configuration here and figure out what's going on. So port 0. Oh yeah, Michael, you're talking about the motion sensor. Yeah, I'm kind of wondering if this is one of the ones that was failed that I was sitting on my desk. But right now I have it. I have 5 volts directly hooked up to that channel. So 0x20 is the MCP 23017. State is 0. Try a different port. Oh, look at that. That's state. That state is 1. Let's see if it changes if I disconnect. No. So wait, now that it's disconnected here though, let's try going back to port 0. Still 0. Okay, well, back to the drawing board, I guess. Hmm. 23017, port 0x0. The device is showing up in the I2C bus. And maybe I do need to ground it. You're right. Let's try that real quick. Might also have connected the MCP wrong on the PCB, so that's something to consider too. But you're right, I left the pin floating right now, so maybe that has something to do with it. So now it's grounded. Still doesn't change the state. Port 0. Invert the logic maybe. Now back to high. No, not really changing, and that should be D0. Let me pull up the schematic here, or actually board file first. definitely hooked up to power. I mean, we're seeing the screen, so, and the Node MCU is active. D0, and let's look at the schematic. So our D0 port goes to GPA 0. Let me see something about the addressing on this thing. Maybe that's what we are doing wrong. Let's readdress. Ajim, thanks for hanging out. Good night. Yeah, we'll pretty much cut off at some point here. I mean, we were about, I'd like to say 50%, probably more like 25% successful with the power supply module working. Some of this stuff isn't, but hey, it's the joys of prototyping. This is definitely a prototype. Alright, so now I switched all the address pins. Oh my goodness. Wait, hold on, how's this? Is that why it wasn't working? Please tell me I had this thing hooked up in there before. And that's why it was, and that's not why it wasn't showing up in the I2C header list. Nope, still not showing up. But that would have been pretty funny if the board was sitting here this whole time. All right. Anyway, now 0x27. So we're definitely addressing the MCP correctly. I just might not be choosing the correct port. State is now -1 on this thing. Oh, because it's not, it doesn't exist. That's why. So port 0. If it's 27, I can't do the math right now. 8 by 16. 148? No, 128. Duh. 128 inputs. So if we are on the last board, or 0x27, and we're using the 0 on that, our port should be 28 minus 16, 21, 12, but it's 0 index, so I'm just guessing at this point. So still -1. Okay, so 0x6f. Okay, I need to spend some time looking at the wiring on the MCP23017. I'm pretty sure it's just a matter of picking the right port to look at. So hopefully -1, still -1. Okay, so we're not looking at the right. The answer is always 42, Zambu. You're right. And we shouldn't be looking at inverse logic anymore. Not that it matters in this case. Still -1. Okay. Well, here's what we'll do. We'll cut off here. I've already been live for an hour and a half. Don't want to keep you guys, looking while I flail here. Definitely need to look at the MCP23017 wiring and to figure out why the ADS1115 didn't get picked up by the board. So there will be another version of the board before I post it on PCBWay. But really, other than that, I mean, the power supply module works. The that was kind of a big deal. The ADIO board, which is this one, is really an expansion board. So I think what I'll do is I'll make the necessary changes to the power supply board and post that up. In the meantime, I'll kind of work on this in my free time, so we can figure out why the MCP2317 stuff doesn't work, or the ADS1115. But yeah, other than that, this thing is pretty well on its way to being complete design. So I think between the baseboard, the power supply board, and the OLED module on top, this is a pretty small stack. You can hook up other sensors to it, but if you use the Ambimate MS4 module, you get 8 built-in sensors. And yeah, that'll definitely be a useful device, I think. I mean, I'm still keeping these around. I'm using them whenever I can. But for the functionality that the Ambimate module gives us, and just all the ease of design and ease of putting it together, I think I like the V2 version better long term. So that will be a lot more presentable, easier to build, and just easier to put together and expand. So free time, what's that? Yeah, you're right, Jared. You know how we all do. We just end up starting a project, and then it leads on to 5 more different projects along the way. So anyway, just a little bit of channel stuff. I did record a couple more videos, so I know I've been slacking on the regular videos lately, but other projects kind of took over my focus. I'm editing those videos now, and hopefully over next, well, either this weekend or this weekend and next weekend, we'll probably have some videos published on the channel. So if you haven't already subscribed and you're here, do so. If you haven't joined the Discord server, the chat, do so, and hope to see everyone around and chat about these projects and others. So thanks very much for joining the chat, joining the live stream, and if you're watching it offline, just follow along with this project with the links below it. So hope everyone has a great weekend, and I'll be signing off now. Thanks again. This is BK Hobby.